Alright, in this video we're going to go over AP Calculus AB 2018 free response question number 2. So they give us an equation to start that is the velocity of a particle moving along the x-axis for a given time interval. They give us the position when time is 0, and question A, find the acceleration of the particle at time t equals 3. Well, hopefully that's straightforward enough. We have velocity, we're asked for acceleration, so A of 3 is just v prime of 3. And this is a calculator allowed question. I mean, you could take this derivative doing some quotient rule with chain rule inside of it, but I would just say go ahead and use your calculator to take this derivative. When you do that, you're going to get about negative 2.118. So that's all for that one. Part B, find the position of the particle at time t equals 3. Well, given velocity, to find the position, we have to take an antiderivative, because since velocity is the derivative of position, we got to go backwards now. But we also have to make sure we consider the initial condition. If all I do is take the definite integral from 0 to 3 of v of t, all I'm going to get is the displacement from 0 to 3. How far have we gone in that time interval? So to figure out the actual position where you actually are, we have to add, well, where did you start? Which was negative 5. So really what we're saying is I started at negative 5 and then I went this far. And so then my final answer, again, calculator, to do that definite integral is just going to be negative 1.760. Now sometimes for a question like this, you have the option of doing this a different way, where you could actually take the antiderivative of v of t by hand and then use the initial condition to figure out the c value, because when you take that antiderivative, you're going to have a plus c. And then once you figure out the plus c, then you just plug in 3 to your actual position function. You're not able to do that here, though, because you can't actually take the antiderivative of this by hand using skills you have from AP Calculus. So this is the only way to do that for this particular problem. Part C really actually just does a nice job of helping us to illustrate what I was saying here, where what does this thing mean? Well, and they changed it to 3.5, but oh well. What this means is the displacement from your starting value to your finishing value there. How far are you from where you started? And we're supposed to evaluate each of those things and then say what they mean. So if we evaluate the first one, the integral from 0 to 3.5 of v of t, calculator allowed, we're going to get 2.844, and that's the displacement of the particle. Displacement of the particle, on 0 less than or equal to t less than or equal to 3.5. Then the next one, the definite integral from 0 to 3.5 of the absolute value of v of t dt, close my absolute value there. Plug that one into your calculator, and you're going to get 3.737 approximately. And what that one means is the total distance traveled by the particle on the given interval. Definitely make sure you include that sort of second part of each of those responses, by the particle on the given interval. displacement of the particle on the given interval. If you just say displacement or total distance traveled, chances are you're going to lose a point there for not being specific, especially including this on the interval part. That's crucial that you have that interval there. Okay, part D, I'm going to clear a little room here. Make sure you've written that down. Pause, rewind, go back. Okay, that should be enough room for part D. So part D, at what time are the two particles moving with the same velocity? Well, that's just saying set their velocities equal to each other and see where that happens. For the first particle, they gave us the velocity. That's the function we've been working with. But for the second one, they gave us the position. So we've got to figure out what's the position, or what's the velocity function based on that position function. So I'm going to call it v2 of t, which is just the derivative of the position, x prime 2 of t, which is 2t minus 1. So I just need to set that equal to v of t. And when I do that and solve that using my calculator, I'm going to get t is about 1.571. Okay? So shorter one there in terms of FRQs here, and that's 2018 number 2.